My presentation today is going to be on my granular synthesizer I'm developing called Grainferno, which is a unique VST granular synthesizer. So a lot of words there people may not be familiar with. I'll hopefully explain all of that in the slides. This presentation is going to go through some background about what is a synthesizer, how does digital audio work, and then it's going to go into some more background about actually a basic demo where we're going to code a audio effect and then put it into a digital audio workstation. And then go over the basics of what is granular synthesis specifically with a demo. And then go over some advanced features that Grainferno offers, some of which I don't think are offered in existing granular synthesizers. Okay. So let's just go over the basic of what is a VST synthesizer. So first of all, we have to ask, what is a synthesizer? That's basically some device which makes sound. Often it includes a keyboard, and so you can play different notes and play your sounds that you've created, that you've programmed at these different notes. And I think most people have seen a synthesizer before, even if you're not aware. So I have this video which shows the DX7 synthesizer, which is very popular in the 80s, using basically all the big hits of the 80s. It's just this big keyboard which makes sounds, all these different sounds, and people would use those to produce records. So I'm going to mute my mic and then mute my mic on Zoom, if I can figure that out. Because I'm going to play audio through here, yeah. How do I do that? So yeah, that was one example of a synthesizer. Grainferno is a different example of a synthesizer, which I'll show you in a second. But a lot of modern producers aren't using only physical analog synthesizers. They're actually using digital synthesizers, so basically just computer programs. And they'll use those in the context of a DAW, which stands for Digital Audio Workstation. Those are the larger programs that music producers use to make music. So examples of those are like GarageBand, Ableton, FL Studio. And then the VST format is what allows programmers to basically plug into the DAW. So the DAW is where producers make music. Independent developers can make programs that will plug into the DAW so that producers can use all these different plugins within the context of the DAW. And so that's what Grainferno is. And the motivation behind creating it was that I should be able to the plugin should be able to create a wide variety of unique sounds, and then producers should be able to use Grainferno in their tracks as basically instruments, right? That they can layer with other instruments or just have on their own. And then also sound designers should be able to create new sounds using this plugin in the context of like movies, games, right, where sound effects are used. And then just some more background on the technical aspect. So this plugin was programmed in C++ using Juice. C++, most people are probably familiar with. It's just a programming language which works at a high level and a low level, which is very important for audio development. You need really efficient low-level access for digital signal processing, but you also want to design like a high-level synthesizer with all these different components. And then Juice is just a C++ framework which helps you create actually a VST and also do some basic things like graphics rendering, support audio files, different plugin formats. It handles that kind of thing. So I use that with C++, and then in the my process of coding, I had a processor and an editor, right? Two main parts of the program. The processor handles the audio, and the editor handles the visual, the UI. And for people familiar with programming, I'm sure you've done some sort of like editor, UI, but audio processing, you may not be familiar with it, so that's what I'll explain the basics of now. Actually, before I get to that, I wanted to do a demo of the Grainferno, so I'm not talking about something that people have no idea what I'm talking about. So let's mute myself again. Okay, so this demo, this demo I will basically put into this synthesizer a sound that already exists, a drum loop, and then I'll mess with it and create all these different sounds from it. Okay, let's try that. Yeah, so that makes no sense, like what's going on, but we'll get to that. There's like this presentation has a whole like arc to it. It's all planned out. Yeah, so basics of digital audio. How do you even like deal with audio in code, right? That's what I'll explain right now. So I have this Desmos, for people who know Desmos. It's Desmos graph. Just hopefully going to explain how digital audio works. So right now you can see displayed a sine wave, right? And we're probably all familiar with that from like high school, sine wave. And that's a good example of an audio signal. In some ways, it's considered the simplest audio signal, sine wave. But the computer doesn't work in this representation of a function, right? In terms of audio. It generally does not represent audio as functions, it represents it as individual points because audio can be a lot more complex than a single sine function. It moves in really unpredictable ways. That's what makes it interesting. So rather than representing it as a function, we represent the individual points that make up the waveform. And so that'll look something like this. Right, so rather than that whole function, we just have some individual points of the waveform with a constant difference in the x value. You can see I'm always moving by 1/10. And then I'm storing whatever the y value is, right? So the x value, those have a constant difference between them at a constant interval. But the y values, that's the data that we actually care about when representing digital audio. Yeah. So with that, we can deal with these individual y values basically and manipulate them to actually manipulate the sound. So for example, here I could multiply each value, right? F of n here is kind of representing each individual y value. Could multiply it by 0.5. And now the wave appears different, and it would also sound different. And I don't know, I'll ask, can anyone tell me like how that would sound different then? Quieter, exactly. We reduce the amplitude so it would sound quieter. And so what I wanted to do is have a quick demo of a Juice plugin that would manipulate audio in some simple way, right? So I've set it up. And it was pretty easy to set up, like the Juice whole producer thing basically sets up the file for you, so it has the basic API stuff there. But then what we're interested in is manipulating the buffer. So this is basically an array of values representing exactly these y values of the waveform, right? So we have all these y values of the waveform. We can do whatever we want with each individual one in this array. But for now, I'll just do something fairly simple and multiply it by 0.5, right? So I'm just doing basic like mutation, multiplying that array value by 0.5. It should be quieter. And then so Juice sets it up. So actually you can export this to the VST plugin and you can run it directly in your DAW. So this should already be set up in FL Studio, which is the DAW that I use. And this plugin is called Basic Demo. And it's going to take a second. So yeah,
so
you have a
is
question?
Juice like a container for custom VSTs or?
Yeah, it's basically like a library. It has stuff for building the VSTs, also the graphics library, and then some other stuff. It's basically just like a C++ library for dealing with audio, although people use it for other things as well. Okay. I'm repeating something I've heard. People use it for other things. I don't actually know, but like, yeah. But yeah, I definitely heard that. So this is just like a basic like drum loop that you might have in a DAW, right? If you're producing music. And now let's pay attention to how that sounds and then pay attention to actually how it sounds when I process it with that plugin that I just built. It says hello world because that's like the default thing. So that's without it. That's with it, right? So it's quieter. So that we were able to change code that change audio that we hear in the context of a music production platform with one line of code, right there. So Yeah, so then we can do something more interesting also, like instead of multiplying by, by 0.5, which would just change the amplitude, let's like take the absolute value of it and then square root it. Right, so now we're actually doing something interesting with each of these individual y values of our waveform. Let's just rebuild it, and then it's all gonna take a minute again, so if anyone has any other questions.
So was that FL Studio that you were showing there?
Yeah, so I had FL Studio, and then I basically had my plugin in FL Studio, manipulating the audio. Okay, so same deal. Wow. Great, we can hear that. And then now I'm gonna drag the plugin in again. And again, every time now it's gonna take this, the absolute value and the square root of the individual point in the wave. Right, so that's with it. Right, so now it sounds like distorted, and that was all just with one line of code. We're just taking absolute value and square root of individual points in the waveform. So that's really what the processor part of an audio program is all it does, right? It just does a lot of math to these y values of a waveform to change how audio sounds. Yeah, so any questions there? Yeah. So this is Xcode, which like Juice just like natively builds to for Mac. Yeah, yeah. So it's already set up very well. Any other, yeah.
And for like compiling everything, are you using Producer or?
Yeah, so like Producer will
Repeat the question for people on the call.
Oh yeah, so there was see, I know the answer, I forgot the question.
For building and compiling like the code, like CMake, or like what do you use for?
Yeah, so for like compiling the code, well, Producer basically compiles it to an Xcode project that's set up for you, and then Xcode actually compiles the code into the VST file. So it's kind of like two steps, but Producer handles a lot of that, like VST settings, so I don't have to manually go into the Xcode and like see where that like variable is set and everything. So.
Also, like putting the VST in your like directory.
Yeah, so I actually already did that. Yeah, it does automatically copy the VST to the standard VST3 folder. Yeah, although I did like do an extra setup thing for that. Sometimes I need to.
Juice and Producer open source?
Producer, I'm not sure. Maybe, I think so, but I'm not sure.
I don't know Producer, like I don't know what our Juice is.
I think Producer might be built in Juice and it might be open source, but I can't really say for certain. But yeah, where were we? Presentation. Okay, so that was the simple plugin coding demo. So now let's get to the demo. What is granular synthesis? Okay, so this is where we actually get to the plugin I'm building and what does it do? So I should be able to open it up in here. Let's get rid of this stuff. Okay, can we see this? Pink. We can hear it, right? Okay. So this is a granular synthesizer. And so synthesizers make sound, right? But each synthesizer makes sound in a different way. This makes sound by taking in some existing sound, which is the waveform that you can see displayed here. And then it takes little chunks of that sound and then rearranges them, puts them together, repitches them, does just all sort of processing on this level of an individual chunk of the sound. So I'll just show you what that sounds like. What does an individual chunk of the sound sound like? So I'm going to change some of the settings to make that clearer. And actually, I'm going to change the audio file I'm using so it's one that people are familiar with. So I'm going to show, this is the audio file that I'm going to put into the plugin. It's just a guitar, right? Guitar recording. And now I'm going to use the plugin to take individual chunks out of that, and we can hear that. right? So we're just hearing individual little chunks. They fade in and out. And that's all granular synthesis really is it makes those chunks of sound. But the interesting thing is how you can change the parameters of the synthesizer to determine where the chunks are taken from in the sound, how fast they occur, and that sort of thing. So we have these basic parameters. Spacing here in this synthesizer determines how fast the grains are generated. And so another term that's associated with that in granular synthesis, inter-onset time, for people who've like looked into it. Right, so the smaller I make it, the faster the grains occur. Size is just how large the grains are. So now they're overlapping. Many grains are overlapping at once, happening at the same time. And another interesting control is velocity, so we can make the grains position of where they're generated from in the original audio file move throughout that individual audio file over time. So I'll set the velocity to a positive value. And actually that is how a lot of stretching algorithms are made, or is with granular synthesis and some idea of that velocity control. We can also make the position in the audio file random. So instead of having it move, right, and that gives a more complex texture to the sound because it's not repeating the same thing over and over again. So yeah, that's the basic idea of granular synthesis. I don't know if there's any questions about that.
So is it generating pieces that you can then use individually, or are you doing just sort of processing over a whole segment?
Yeah, well, so the individual pieces you can process separately, and they are, but it's kind of more of like a macro controls of how you're going to change how you generate these individual pieces over time, right? So, for example, as I move this like pitch knob, every time a grain is generated, which is at quite a fast rate, it's taking the value, a pitch value of wherever this knob is, and that's the pitch value for that grain. And does that answer the question?
Well, so would you use this as like an instrument, or is it more just like an effect process?
So you could definitely use it as an instrument. For example, you could kind of like narrow in on one piece of a sound that you want to repeat. That's not a great example. Right, to repitch it. But actually there's another interesting way that this would be used as a instrument, which I'll get to a little bit later in the presentation. But yeah, that's the basic idea of a granular synthesizer. I basically went over those. And then there's an internal modulation system. So a lot of synthesizers now have internal modulation systems. So all these parameters that I've been manually controlling can be automatically controlled in different ways. So for example, I could have the spacing move up and down over time automatically rather than manually changing it. Right, so I've made an LFO, I've made the shape which controls how the spacing moves over time, and I have a rate of how fast it moves. I can like combine that with some velocity which changes. Right, and we can create like interesting effects on the audio. And there's also randomness control. So any of these parameters can be made to be random, and the randomness works on an individual grain level. So each time a grain is generated, it takes a random value from this range of randomness that you've selected. So for example, I can make the pitch of each grain random. So we're gonna get a really chaotic sound. Each time a little chunk is generated, it's gonna be at a random pitch. So it's not everything's at the same pitch. Right, so you can create like interesting sounds like that with that. Or I think a simpler example would be to randomize the panning. So each time a grain is generated, the position in the stereo field is random. So it's like in your right ear, left ear, center. And that's, you would like need headphones on to hear that, but yeah, that's basically the modulation system. Just to go over it, the synthesizer has 3 envelopes, 3 LFOs, 3 randomness controls, and it's drag and drop. So I've been just dragging from the modulator to the knob I wanted to affect, and then that makes the link, basically. Okay, so any questions there?
Yeah, can you use MIDI controls to, instead of the modulators, for example, to control those?
Yeah, so you can like link a MIDI knob to any of these knobs. And I've done that sometimes. It can be fun, yeah, for sure. And then you can also link, for example, a MIDI control to like the rate of an LFO. So you can be controlling something, which is controlling something else. So it's very flexible in that way.
I have an implementation question.
Yeah.
Because like with the most basic like granular approach, it would be like a single voice, right? So you can't get overlapping, but you showed
Yeah.
overlapping.
Yes.
Do you have like several buffers at the same time?
Yeah, so I have like an array, I think it's like 50
Okay.
per voice, right? Because you can have multiple notes also, which would have their own grain handling per note. And yeah, so it's like 50. I'm not like allocating new ones. They're just 50, and then you're taking whichever one's available at a given time. Yeah, exactly. Great question. Okay. Okay, so what are some unique features of Grainferno? So tonal granulation. So when grain generation, okay, this is the idea of like, what does tonal generation mean? So if any audio event happens at audio rate is between 20 hertz and 20 kilohertz. This is the range of human hearing. If you've ever done like a test of your hearing and it like has a frequency that moves upwards, this is generally the frequencies we can hear. Things that happen, audio events that happen lower than this rate, we can hear as individual audio events. So for example, volume going up and down at a rate of like 1 hertz, 1 time per second, we would hear that going up and down. But if it happens at a higher rate within the range of human hearing, we hear it as a tone, just like a psychoacoustic phenomenon. So if we can generate grains at audio rate, we can actually synthesize a tone based on the rate of grain generation. So if we generate grains at 400 hertz, we hear a tone that happens, or that is at 400 hertz. And then we can like shape the tone with all those granular controls. So let's see an example of that. Get rid of this stuff. Get to a good section. Okay. So right now I'm gonna make it not overlap, and I'm gonna make the grains spaced out pretty far. We hear those individual bumps, right? The individual grains. And then as I make them faster and faster, closer and closer together, we start hearing the individual grains. We start hearing a tone, a single tone. Just make sure I'm positioned here. Yeah, it has an interesting sound, but yeah, so that's why the spacing knob is measured in octaves. So it's minus some octaves, some amount of octaves from the note that you're playing. So actually this is key mapped automatically. Right, so now we have a tone, which should be a C, because I'm playing a C on my keyboard. And we can play different notes and we'll hear those different tones. So now we've basically created a tone which doesn't sound too much like the original sound but from the original sound. And we can shape it in interesting ways. So for example, now if we modify the pitch, actually, since the pitch is now coming from spacing control, we're not going to hear that as a change in pitch, but we'll hear it as a change in timbre. So let's do that. Right, so now we're hearing some like more interesting synthesized tone, but still just derived from the original sample. And I can do like size. So basically all these controls will have some timbral effect now. Right, so now we can create basically synthesizer tones, but with granular synthesis. And if I were to, I could slowly morph back in. Back to the original tone. Right, so we can kind of go back and forth between those two different ideas. Okay, so there were some challenges in doing tonal granulation. When we're dealing with digital audio, like I went over, we're dealing with discrete values of a waveform at constant distances apart, which I showed as 0.1. The problem is, and by the way, that's referred to as the sample rate for people who have a background in digital audio. The problem with generating grains at audio rate, precise tones, is that that tone that we're trying to produce may not be divisible by the sample rate. So for example, if the sample rate is 44,100, 44.1 kilohertz, that means there's 44.1 thousand discrete values of the waveform that we're dealing with per second. But what if we want the grains to be generated at 400 hertz, right? 400 times per second. Well, that means they're occurring every 110.25 samples. So that means a grain needs to start before one of these values that we're actually holding for the waveform actually occurs, right? It needs to happen in between these sample positions. So I had to come up with some idea shifting kind of the position that we're taking from in the waveform, interpolating that, right? So we're actually taking a position in between the samples of the waveform to kind of original waveform, right? The sample that we're using that we've dragged into the synthesizer to account for that. So kind of to counteract the shifting that naturally occurs when we're dealing with like a set sample rate. And so this has to do with sync interpolation. So that basically is there's this way that we can find the values in between the discrete values of the waveform that we have. So I won't go like super in depth into it. It has to do with like impulses and like band limited stuff and like digital signal processing stuff. But basically, yeah, we use this sync function. We consider it for each sample in the waveform. That's what it looks like when considered for each sample. We add that up. So now instead of, we basically represent, instead of individual samples, caring about them as individual samples, we consider them as like sync functions emanating from that space and time. And that reconstructs, right? So this is reconstructed completely just from those discrete sample points, but we can reconstruct the original waveform. So we see the sine wave again. And if I, for example, make a more complex waveform, so let's add a sine wave on top of that. Right, now we can reconstruct that as well. So we're reconstructing an original signal just from those discrete points. That's what you need to do to interpolate, find the values in between those discrete points that you have. And yeah, so that's how the tonal granulation was achieved. The other unique feature would be the granular compression. So for people familiar with traditional compression, you basically average out a signal over time, how loud it is, and then you squash the loudness of the signal, so it's a more consistent volume. This is super common in music production, or like even like podcasters will like use this. So it's like they're at a more consistent volume the whole time, right? So there's not like loud spikes. So I use this idea of compression with granular synthesis, and rather than compressing an entire signal, right, which would be the result of all the grains, I'm compressing individual grains at a time. So I compute the RMS value of an entire grain when it's generated, and then I plug that into some function to see what I want the loudness to actually be. So the idea is I take very quiet grains and I make them much louder. And already loud grains, I don't make much louder, or I have them be at the same exact volume. So that makes a more consistent volume for all the individual grains, which gives us an interesting kind of compression with unbounded look ahead and without latency. So normally like look ahead is a whole thing of compression, seeing into the future of where the signal is going to go, but it's not a problem here because we're dealing with a sample that's already like pre-computed. And this is good for like a granular synthesis approach, because now each grain isn't like affecting each other in terms of the volume. They're all independent and we can do interesting things there. So I'll do a quick demo of that, like a drum loop. No. That's something with like a lot of dynamics, right? There's those loud hits of the drums and there's kind of the space in between. And so what the compression is going to do is basically make those spaces in between actually almost as loud as the loud drum hits. So I'll first play without any compression. That's kind of like a weird phased version of the original signal, but now if I compress it, oh wow, it's loud. So now all of those individual little chunks of audio are at a basically consistent volume. So we're hearing the small details just as much as like the loud impacts of the signal. And so that pretty much covers the unique features, I think. Yeah, so that pretty much wraps up the presentation. I guess I'll ask if anyone has any questions. Yeah.
So is the compressor like an upwards compressor?
You want to start with now so people can hear it?
Is the granular compression using upwards compression or downwards compression if we're...
So technically,
Now you have to.
technically, I guess technically it's not compression, it's expansion. I've been looking into this. It's like, I don't really care about those differences in definition. It's just like different functions that you're using. But yeah, this one, it's actually based on like radicals, so like square root, right? Because square root bounded between 0 and 1 will basically increase from an x to a y value. And so it's like square root or like cube root or like quad root. And that's basically what you're controlling, is like how much you're pulling up those very quiet sounds. So yeah, oh yeah.
Okay, I think I'm close enough to your mic that I can just ask
Okay,
a question.
yeah.
But I have a high-level question, which is maybe close to the question was asking earlier. I'm coming from a classical performance background, so this is a great introduction to the digital world. And I'm wondering, when do people use a tool like this? Like, is it like I've composed something and then I'm like trying to tweak the sounds to make it even more interesting, or like what I'm looking for a new type of sound to put into my song? Like, when do people actually use it?
Yeah, so it's very open-ended actually, and both of those would be great use cases. So yeah, you could, for example, take like an existing like drum loop, just like I just did, process it in an interesting way, and then use that as the drums in your track. Or you could take like a piano recording, isolate one note from it, and make some basically instrument from that one note, right? Or you could have a whole performance just based on one sample in there, and you're manipulating the knobs for like 10 minutes. And I've done that. It's maybe not the most popular kind of music, but yeah.
Do you have people using it for music that they're creating?
So, I mean, right now I'm like hoping to release it as a synthesizer, but it's like in beta testing now. So there's some people beta testing it and they've messed around with it. And mostly what they're doing is this genre of music called botanica. I don't know if people have heard that. Some people have. It's like this new like hip genre with like people younger than me are making. But it's like all these like organic sounds and like, but like mixed or like processed like with computers. And it's like a whole like aesthetic to it. It's cool. I think it's cool. But
Is there like
yeah, no, exactly.
that you found that are like, whoa, we're really into these?
Yeah, I just like spam my stuff everywhere. And so sometimes it like catches on to certain people. Yeah.
That's amazing.
Yeah.
Yeah, I'm curious, like, that's follow-up, like, where did you find these botanic people?
Yeah, so where did I find the Botanic? I think I was like on like a Discord server, and then like I posted the thing. I was like, oh, I made this synthesizer, and then someone tried it out, and they were making Botanica. They're like, oh, you gotta talk to all these other people who are making it. Yeah, it's gonna be a big thing in like 2 years for sure, for sure. I hope so. I think it's cool. Yeah.
Oh, like what was your background? Like more like in terms of background to like making this, did you come from more like a computer science background or like a musical background? Kind of what made you want to like make something like this?
Yeah. So yeah, I was mostly from, well, I like studied computer science in school, but also I've been producing music since I was like 12. So, and I've always wanted to like make a synthesizer because I use them like every single day. I love this stuff. So yeah, I just decided to once I graduated from college, like start working on this project.
So when we're trying to do this, what you're showing here, in like let's say like Ableton, how long would it take you like to do something like in yours, like, for example, like the modular or like Grainferno versus like doing that in
So you mean like using Ableton's granulator?
yeah, Grainferno versus yours?
Yeah, so I'm not like super familiar with the granulator. I don't think it has like the nice tonal setup where you can like track and it like makes the nice clean tones. Ableton does have like built-in like LFOs and stuff, but it's a little bit less intuitive to use like those and like all those other parts. I don't think it has like an internal modulation system, granulator. And then additionally, like it's not having some of the controls like the compression, but you can definitely like granulator is a great choice. Even like FL Studio comes with Fruity Granulizer, which you can do a lot with. So like there's a lot of this software out there. I just tried to make one that like really fit my tastes. Yeah.
I'll say like, following up on this thing, I've used a lot of granular plugins, but granular compression I've not seen, like specifically granular compression I've not seen used before. So I think that's like a really, really interesting tool to be using.
Yeah, okay, thank you. Yeah, hopefully, yeah.
We got a quote from him.
Yes, it's a new tool, yeah. Yeah, I actually, what happened was CRM2 came out for people who like follow synthesizers. Oh my God. Very impressive like synthesizer, and actually has like has the tonal aspect, granular, which nothing really did. Like I was developing this for months, nothing really had that. CRM2 came out like last month, and yeah. But whatever, I'm still proud of my work, so it doesn't affect that.
If we want to use it or be a beta tester, is that?
Yes, so that's the very next slide.
Okay.
Okay, there's 2 QR codes. There's Discord, and then I hear some people do not like to use Discord, so there's also an email newsletter. Currently, no one's on that.
This whole thing's going to be posted online, so.
Oh, awesome, yeah.
Yeah.
Okay.
Okay, thank you.
On the website, so people can just.
Yeah.
You carry your picture?
Do I do what?
Carry your picture?
What?
Carry your picture.
Oh, for like contact?
I don't know how I feel about email newsletter. It's a little too high tech.
Discord, you can do Discord though?
It's even more high tech.
Okay, yeah, going door to door was the next strategy, and like flyers. So I'm gonna communicate, yeah, that way. But carrier pigeon I've not looked into. Yeah, so if you want to like beta test, the Discord, there's like the beta versions you can test. Email, you can find out like when it's released for real. And there will be a standalone version, so even if you don't use like a digital audio workstation, you can still like use this.